Hello everyone. In this video lecture, we are going to discuss on attack specific ML models. So this attack specific ML models are used to enhance cyber defense with ML approaches. So we will see what is this attack specific machine learning models are. Like in cyber security, threats are evolving day by day, and more number of threats are generating because of this complex and adaptive nature of the internet. So traditional security mechanisms like firewalls, intrusion detections are based on signature based and antivirus solutions. So these will not sufficient, or this can't able to provide solutions for modern digital signatures. Machine learning approaches introduces intelligence into cyber security, where it enables systems to learn patterns from data rather than relying on predefined rules. But a single generalized ML model cannot effectively capture the diverse behaviors. So what we can do, what is the solution means? For example, we can say malware operates on system level, but the phishing attacks will operate on application level, or it's based on human behavior, and DDoS attacks are based on network traffic volume. So the attack itself has diverse characterizations. So like this type of attacks, we need to address these types of attacks. So how we will address this type of attacks means we have to find attack specific machine learning models which will help us to solve the particular solutions for the given cyber detection, cyber attacks. Like how by using what type of attack solutions or attack defense we can take by these ML models. All these things we will see in this video lecture. Further, we will also see so how we can improve our detection accuracy and reduce false positives and improve systems efficiency. Now we will see so why attack specific models. As we saw, like cyber attacks differ fundamentally in their objective, execution methods, and observable features. So a generalized machine learning model must learn multiple unrelated attack patterns, which simultaneously results in confusion or poor generalization. Like attack specific models are needed where it will detect precision, performance, efficiency. Like it will select the most relevant features for each attack type. So like ML algorithms which best suited to particular attacks behaviors. Like we need to reduce noise for the particular features. Example, we can say a phishing detection requires linguistic and semantic analysis. Phishing attacks in email phishing, we can say. So for that you need to use natural language processing. In that natural language processing, you have to identify whether it is a spam or not spam. So for this, it need to understand linguistic and semantic analysis. But if you consider the DDoS attacks are distributed denial of service attacks. So where it either it will affect your network layer or transport layer, or from physical layer itself it will produce jamming attacks like that. So like when you are going particular layer, so layer specific attacks, so attack specific models need to be evolved, where it will it will enhance the detection precision, faster inference, and better zero day detection capabilities. So it simply simplifies models which are which will give you some interpretation and tuning according to the situations. Like ML models, what are the ML models we can use for malware detection is, so malware detection means it is particularly aiming you to find the software attacks, like malicious software is installed, and whether the system integrity, confidentiality, or availability has been compromised. Like traditional signature based antivirus failed against polymorphic attacks and zero day malware, but this machine learning addresses these limitations by learning behavioral patterns, so rather than the static signatures. So we can say that random forest algorithm or gradient boosting XGBoost algorithms widely used to detect these types of malwares because they handle high dimensional feature space and non-linear relationships between the features. Further, we can see convolution neural networks are used to extract spatial patterns from malware binaries and opcode sequences or from memory dumps. So, like these features, we can say API call patterns means like file access, registry modification, bytecode analysis means like patterns and opcode frequency, behavioral logs such as process creation and network activity. So, these models enables early malware detection systems where the execution completes significantly reducing the damage. So next we will see ML models for phishing detection. So phishing aims to deceive users into revealing sensitive information such as passwords and financial details. Like these attacks rely on heavily on our application layer. It mainly focuses on text URLs and social engineering techniques. So, like how many users he is connecting, what are social media details, whatever like that. So, what type of machine learning algorithms used for this is logistic regression and naive-based classifier. So where these are effective in text classifications, and these tasks are used to simplify and interpret the particular task, and but they also have some struggle with contextual understanding. So to overcome that, we can use transform based NLP models such as BERT and Robert, uh, address where it addresses the limitations by capturing contextual semantics and word relationship. So you can try if you are going for this type of attacks. So next, like email, for example, I can say the ML models for this email attacks will have some subject lines and body content, or it will have some URL structure and domain repetition. It will identify center behavior or metadata. So these type of models will help to detect phishing emails where it will the legitimate communications will not suffer. And now it is like DDoS attacks detection. So DDoS attacks mainly floods the networks with excessive traffic to exhaust resources and disrupt services. So signature based systems often detect attacks only after significant damage has occurred. But with the help of machine learning techniques like decision tree, SVM classify traffic patterns by learning normal versus abnormal behavior. So LSTM long short term memory, so are particularly powerful for modeling traffic over time, and they capture sudden spikes and abnormal traffics in the patterns. The important features like what we can say is packet arrival rate. So what packet arrival rate will give is how many packets arrived. So particular time instance, say 50 seconds or 1 minute. So how many packets are arrived. So any deviation if you see in the packet, then it can be used to detect that attack using these models. And connection count. So connection number of concurrent connections. So how many connections are established from source node to destination node. So connection count. So this is also one important feature where we can detect attacks using this connection count. And traffic burst, like traffic spikes, traffic burst pattern. So what is the normal pattern? So you in an organization, but if any traffic burst or traffic spikes occurs, there we can identify the abnormal behavior pattern so that we can alert and we can identify solutions to detect these types of attacks in real time. So these ML models will help you to identify or play a key role in identification that packet arrival rate, any deviation in packet arrival rate, or any number of concurrent connections are there, or traffic burst in the patent. All these things can be identified by using these patterns. And what are the ML models are used for intrusion detection systems is, so intrusion detection means like you are detecting the intruders. So for that you are framing a system. Either you can do it on the server, or some 10 systems are there. You can make what are the activities are happening in the 10 system. Either it can be LAN or local area network, or you can deploy the intrusion detection systems in wireless area networks like that. many things you can do with this IDS to detect attacks. Like IDS mainly monitors networks and host activities to detect unauthorized activities or unauthorized access, or it is used to detect some malicious behavior. So how ML helps or ML enhances IDS is, so it enables anomaly detection and adaptive learning. Means, so we can say with an example, so it uses random forest techniques. So random forest techniques provide robust classification for given patterns, whether it is normal traffic or attacked packets, any spike like previously we saw, or KNN. So KNN also detect a similarity based anomalies. Then if you see deep auto encoders learn compressed representations of normal behavior and flag deviations as potential intrusions. Like we can use various types of data sets for that. So the best data set you can use is NSL KDD and CIC IDS 2017 are widely used to train and evaluate IDS models. ML based attack patterns, like they can detect both known and unknown attacks, so which significantly outperform traditional rule based systems. So next is some models for botnet and malware traffic detection. So how you can use botnets. Botnets, what is botnet? It consists of compromised machines. Okay, it's the compromised machines which controls the attackers through command and control channels. Like detecting this type of botnet is a challenging because it has encrypted and distributed communication. So for this type of things, you can use unsupervised machine learning algorithms. So we can say the best unsupervised detection is K-means clustering algorithm, where it identifies anomalous traffic without labeled data. And we can also use CNNs, so which is used to analyze traffic level patterns. But the GNNs, graph neural networks, also used to detect command to control structure, so where the relationship between the host is to detect coordinated behavior. So we can use features like DNS, query patterns, traffic directions, peer-to-peer communications. And if you see, GNNs are particularly effective in identifying hidden botnet structures. So you can also use this GNNs to detect this type of malware traffic detections. So next is ML model for insider threat detection. So insider are people where they will look like legitimate user. So but they will abuse the authorized access. So slowly they will get access. So it's very difficult to detect this type of insider threats because people who are in the organization itself act as an insiders, and they will slowly steal your data. And these attacks, like it is very difficult to detect because it resemble normal activity. Then how to detect this type of attacks means we can use this SVM models. So SVM models where it identifies user behaviors. So user behavior, if you want to identify user behavior, you can deploy this SVM model, and what are the flags deviation occurs. And similarly, we can also use auto encoders to detect anomalies in the attack access pattern. So further, we can use reinforcement learning in algorithms, where it uses adaptive monitoring strategies. The features what we can collect the features to involve in these algorithms are like login time pattern. So when the user is being logged in and when he is logging out, so what are the activities he is doing, activity logs we can collect. So from this log we can analyze his behavior modeling. So we can say particular behavior. If any deviation in the behavior of a particular user, then it will classify it as an abnormal activity. And then access time, so access time patterns, like timing. So for doing particular task, what is the user is doing, if the user deviates from that task, then it and a log and active and log can be generated based on his activity. And then privilege misuse signals. So for example, in an organization, so administrators will be given more privilege. So in that type, he should not be an insider attack. In that case, if he's insider, then how he is violating his privileges, or how he is exploiting his privileges, all these things can be analyzed. Then how what are the evaluation metrics we can see is accuracy. But as we discussed, accuracy alone is not enough. Like recall is a critical thing, because missing an attack can have severe consequences. So this recall is very very important. And then precision reduces false alarm and analyzes the fatigues, and F1 score balances both of this. Then you have to consider this false positive rate, where it is a normal pattern or attack pattern. It directly impacts operational behavior. It's like cyber security evaluations must balance between all these factors with effectiveness and usability. Then what are the advantages of these ML models? Are like this ML attack specific ML models improve accuracy, scalability, and adaptability, where both hybrid and ML and deep learning models can be combined to detect cyber threat intelligence for the situation awareness. The future lies in autonomous AI driven security systems which are capable of self learning and self healing model. Then real time intrusion detection systems using ML models. We can also use real time detection with this ML model. How it can be achieved is the real time detection is very important, where it minimizes the damage of an organization. What we can do is we can do some network IDs, monitor traffic, like host IDs and system level activity. The real time detection plays a major role, where it has is essential for performing high speed networks. And why machine learning is needed for real time networks is machine learning enables zero day detection, where the adaptive machine learning reduces manual rule management. It continuously learns evolving normal behavior, making it ideal and for different environments. So it will adapt to the particular situation, and where we can find the solution for the attack patterns. So real-time ideas, architecture and data flow, how the real-time architectures, what you will take as a data means you can take the capture the packets. So you can use many tools. Many real-time tools are available like Wireshark, NetFlow, IPFix, or you can collect host logs, system calls, or these are used to do the telemetry processing. Okay, so these features you can take, and you can identify, you can form some pipelines to detect these attacks. So from these patterns, you can use whether what is the latency of the packets being transferred. If the latency is low, or if the latency is high, based on that you can act, what you can do like that. So these real-time ideas techniques will use the ML model to perform low latency predictions, triggering alerts or automated responses when we can detect the threats. The pipeline must be optimized, speed and reliability, scalability, everything need to be discussed. So next is a feature engineering for real-time detection. So feature engineering is important thing, where real-time ideas focuses on flow level, temporal and host-based attributes. So sliding window statistics capture short-term behavior changes, while graph-based features model communication relationships. So efficient feature computation is critical to maintain low latency. So next is what are the ML models which are suitable for real-time ideas is like we can say logistic regression, decision trees, and pruned random forest. These are time series models where they will provide LSTM, are used to selectively optimize, and anomaly detection models are used to find isolation forest, and streaming autoencoders are also used to detect unknown threats. The hybrid architectures combine fast detectors with deeper secondary analysis. So next week latency, streaming infrastructure, and low latency systems. In this, the real-time ideas depends on effective streaming infrastructure. Some message brokers handle data ingestion, stream processing engines manage real-time computation, and optimized model serves as frameworks which enables low latency interference. Decisions about edge versus cloud deployment also need to be considered to improve performance, cost, and privacy. So next, what are the evaluation metrics for this real time is beyond the detection accuracy. We can have the metrics such as mean time to detect and mean time to respond, MTTR or false positive rates, and then we can have some inference latency in milliseconds, throughput, what is the throughput of the systems, and how much memory or CPU costs to work particular things. All those things can be considered. Then the common challenges and mitigation techniques like and real-time IDS faces challenges like data imbalance, concept drift, adverse elevation, high false positives. Further, the mitigation will suffer for synthetic data generations, continuous learning, robust model design, and human in the loop validation. So all these things should be considered. So what are the best practices you can do with this solution topic is like you have to successfully deploy the attack specific ML models which require a clear threat reproducible feature pipelines with hybrid detection architectures. It should be a continuous feedback of a loop and strong governance. Like you can also adapt explainability and model monitoring services for long-term trust and effectiveness. So this attack-specific machine learning models represent a critical evaluation in cybersecurity, which enables precious, adaptive, and scalable defense mechanisms, which aligns ML models with specific attack behaviors and deploying them in real-time architectures, where the organizations can move from reactive defense to intelligence autonomous security. I hope you understand the importance of attack-specific machine learning models in real time as well as in normal IDS systems. So soon we will meet with the next lecture. Thank you.